Hello. Today, we'll solve a series-related proof problem using mathematical induction. If you are new to my channel, I recommend watching my previous video that provides a detailed explanation of mathematical induction, accessible through the link in the top right corner. Mathematical induction can be likened to knocking down dominoes, and to topple all the dominoes, the following two conditions are necessary. Number 1, the first block falls. Number 2, if the kth block falls, then the k plus 1th block also falls. If these two conditions are met, we can conclude that all domino blocks will fall. To prove the problem displayed on the screen using mathematical induction, we'll break it down into 5 steps. The step of assigning a name to the given problem is denoted as n. The step of checking if the first term is true is denoted as 1. The k step representing when the kth term is true. Then the k plus 1 step for verifying if the next term p of k plus 1 is true. And finally, the step of writing the conclusion is denoted as c. Specifically, there are characteristics of sigma that need to be utilized in the process of this series. If you calculate the sum of the a sub r from the first term to the k plus 1th term, it becomes a sub 1 plus a sub 2 plus a sub k plus a sub k plus 1. The sum of the initial k terms can be expressed as the sum of a sub r as r goes from 1 to k. The property I have shown now will be reused later in the proof. Let's examine the first step, which is assigning a name to the problem, denoted as n. We'll call p sub n the sum of r times r factorial as r goes from 1 to n, and this value is equal to n plus 1 factorial minus 1. For a more convenient proof, we'll refer to the left side as L and the right side as R. Now let's start the second step, which is checking if the first term is true. The left side, p sub 1, is the sum of r times r factorial as r goes from 1 to 1, making it 1 times 1 factorial, which is equal to 1. The right side, p sub 1, with the n replaced by 1, becomes 1 plus 1 factorial minus 1, resulting in 2 minus 1, which is 1. Since the left side p sub 1 is equal to right side p sub 1, the first term p sub 1 is true. The second step is to assume that the kth domino falls, and the third step will prove whether the next domino, the k plus 1th domino, falls. If the kth domino falls, that is, if p sub k is true, then the sum of r times r factorial as r goes from 1 to k is k plus 1 factorial minus 1. Now let's check whether the k plus 1 domino falls. Just as we did when verifying if p1 is true, let's calculate the left and right side separately to see if they are equal. First, the left side p sub k plus 1 is the sum of r times r factorial as r goes from 1 to k plus 1, which starts with 1 times 1 factorial plus 2 times 2 factorial, and continues to k times k factorial plus k plus 1 times k plus 1 factorial. However, the underlined sum up to the kth term can be expressed as the sum of r times r factorial as r goes from 1 to k, and adding k plus 1 times k plus 1 factorial at the end completes the left side. Looking at the yellow box above, the sigma sum is equal to k plus 1 factorial minus 1, so we can substitute it in. Then the left side becomes k plus 1 factorial minus 1 plus k plus 1 times k plus 1 factorial. And rewriting it, we get k plus 1 factorial plus k plus 1 times k plus 1 factorial minus 1. In this expression, the underlined k plus 1 factorial is a common factor. So factorizing it out, we have k plus 1 factorial times 1 plus k plus 1 minus 1. And simplifying the expression, it becomes k plus 1 factorial times k plus 2 minus 1. Since k plus 1 factorial times k plus 2 can be written as k plus 2 factorial, the left side ultimately becomes k plus 2 factorial minus 1. Now let's examine the right side. To find p sub k plus 1 on the right side, if we substitute k plus 1 for k in the formula, p sub k is k plus 1 factorial minus 1, then p sub k plus 1 becomes k plus 1 factorial minus 1, ultimately resulting in k plus 2 factorial minus 1. Since the result of the left side and the right side are the same, we have shown that P sub k plus 1 is true. In other words, when the kth domino falls, the immediately following domino, the k plus 1th domino, also falls. Now only the last step C remains. Let's write the conclusion and conclude the proof. Since P sub 1 is true, and P sub k plus 1 is true whenever P sub k is true, therefore P sub n is true for all positive integers n. Today, we applied mathematical induction to solve a series problem. In the next session, we'll explore other types of problems such as sequences, trigonometry, inequalities, and derivatives. If you found this video helpful, please subscribe and like. Thanks for tuning in, and I'm your math guardian, Alex.